Alright, the following limits, I will leave them so that you can practice. And I will move on to the second section, which tells me evaluate the limit and justify each step by indicating the appropriate limit laws. So it's again the same. I have several numbers, functions, and I want to find the limit. So here I can do this limit of 2x squared as x approaches 1 minus the limit of 2x as x approaches 1 plus the limit of 4 as x approaches 1. You see? So again, I also have to apply properties one more time. Here I can take these two out because constants can be taken out of the limit. They are not affecting my limit. Here it's the same. I would take that out, that number 2, like this. And here I know that the limit of a constant number is that constant. Okay, I will continue here. So my first limit is 1 because I am replacing that x with the 1 because I know that x squared is a graph that looks like this, and I know that this graph is not a piecewise function. It's not a rational function which has discontinuities or asymptotes or anything. The domain of this function is all the real numbers. Because I am sure of that, I can just replace that x with 1. And for the second one, the function is just x that is a line, something like this. The same happens. This is not a piecewise function, this is not a rational function with asymptotes or anything weird. So I can just replace x with 1. Okay, 2 times 1, that is 2. 2 times 1, again, 2, that is 0. Okay, so the limit is 0. And that is the same for this limit and these limits. Okay, it's pretty much using the rules of limits. Let's take this one for example. What will happen in this case? It'll happen that when you try to find, first you have to divide it into two limits, one for the numerator and 1 for the denominator as x approaches -3. I will take a look, whenever I have rational functions, I will try to take a look first at the denominator, because the denominator is the one that sometimes gets tricky. So I will deal with that limit first. What is the limit here? As x approaches -3. Here, what you would have is -3 plus 3, which is 0. That will give me a number here over a 0. You know, for this exercise, we're not dealing with limits to infinity. So for this one, I would just go and write does not exist. Okay. So when you have these fractional functions, please be aware of that. Please, it's recommended that you start by taking the limit of the denominator, just as I did it. And I saved out some time because I didn't even have to compute these limits here, because I realized that here I have a 0. Yeah, that's pretty much the activity. And the rest exercises are meant for you to practice.